Okay, hello Cloud Gurus, and welcome to another installment on this challenge lab. Now, for many of the labs, I recommend that you first watch me do the lab through once, and then you yourself go ahead and do it. But for this challenge lab, we're doing everything in reverse. Now, I've already described what we want to accomplish, and I want you to go and make that happen before you watch me do it. In this lecture, we're going to look at the data flow that we want, both what we ourselves do and also what happens behind the scenes because of what we do. Now, whether you've already accomplished the challenge or whether you're going through this because you want some hints, as I go through this data flow, think about how it compares to your mental model. Did you already realize what was happening in each step? And if so, were you already thinking it before I said it? Or was it just that it seemed familiar once I had? In any case, as we go, try to refine your mental model. Okay, so let's just remind ourselves quickly of the desired result. We want a brand new project with a GCE instance that runs the script that I've provided. We want the system logs to show up in Stackdriver logs. We want to have a new GCS bucket for the resulting log files. And we want the log file to appear in that new bucket after the instance finishes starting up. Now, throughout all of this, there's no need to SSH to the instance itself. It should handle all of those things on its own. So let me summarize then what our actions are going to be. What is it that we're going to do in this lab? Or hopefully, what is it that you've already done? Now, the first thing is that we need to look at that startup script. It definitely has important information in it. After that, we'll make a new project, make ourselves the logs destination bucket, enable the Google Compute Engine API. Now, this is automatic if you do this through the console, but it's definitely something that you need to consider if you're doing it through the command line. After that, we'll create the new GCE instance. And some key things that we need to set there are that we need to enable the scope to write to GCS, optionally set some labels, set the startup script, and add a new piece of metadata that points to that logs destination bucket. After that, a lot of stuff happens autonomously. But we will take a look at the progress by looking at the Stackdriver logs, the CPU graph in the GCE monitoring tab, and the file that shows up in the logs bucket. Well, without further ado, let's take a look at the data flow in action. We start things off with your machine, the computer you're using to run your web browser that connects to the GCP console. Now, once you have connected to the console, you can connect to Cloud Shell and its editor to get access to the course lab files. Those are stored in Cloud Shell's persistent storage, and you load the startup script into the web browser tab. Now, for this lab, that's really all you need Cloud Shell for, and you could just as well get that startup script by clicking on the resource in the lecture where I introduce this challenge lab. Now, one of the first things we need to do is to create a project, because that's the bucket that will contain all of the rest of the resources. So we reach out to Google's project control and ask it to create us this challenge lab project. Then we'll select the project in the GCP console, and from that point on, everything that the GCP console does will be in the context of that project. I'm not going to go into every single detail here, but when the project is created, a number of different services are enabled by default, and some others aren't. As it relates to this lab, the Google Cloud Storage and Stackdriver services are enabled by default, but Google Compute Engine is not. So given that GCS is enabled, the console can talk to GCS and say, "I would like a bucket with this name, please." That logs bucket is then created, and the console is told that it was successful. The next thing we do in the console is to navigate to the Google Compute Engine area. But because GCE is not enabled by default, the console talks to Service API Control for us and asks it to turn on the API. That will then reach out to GCE inside of Google behind the scenes and initialize the things that are needed. At that point, the API is turned on, and the console is told that it can go ahead and talk directly to GCE from this point on. So in the console, we do ask GCE to create a new instance for us. We give it the configuration information, where we pass the script that we had loaded in our web browser already. We pass a reference to the bucket that we just created as custom metadata, and we set the scopes that are supposed to be used for this instance. Now, another thing that's very important, but that we don't have to change, is that we want to use the default service account. This gets stored as a part of the instance configuration and will come into play in a little bit. Now, once this information has been passed to the GCE control plane, the rest of what happens here is asynchronous. There is nothing more that Google needs from us, our machine, or our console web app. Everything from this point on will happen completely automatically, except for when we look into things, I mean. But think about what we've given it, really. We didn't give it an actual machine, neither physical nor virtual, and we didn't even really create a machine at this point. All we've given Google is a template for creating a machine, and Google has accepted our request to create that machine from this template right now. So it wouldn't matter if we turned off our machine, lost our internet connection, or just ignored it for a long while and came back later. Everything from this point on would happen the same way anyway. Now, for the sake of this data flow, let's bring our machine back and leave the web browser with the Google console open, because we'll use it to look into some things later on. So now that GCE has gotten a request to create a machine, it needs to go and find itself a host machine somewhere that has free space for this VM. The host machine that it picks will depend on what instance type we've given it. The location of that machine will of course depend on the region and zone that we selected. And Google will manage the problem of trying to pack all of the different instances onto the different hosts most efficiently, so that there aren't wasted resources. Now that host machine will then reserve some space for the GCE instance, but there's more going on this host than just that. One of the important things to understand is that the host machine itself is always running the metadata service. And this is why you can connect from a GCE instance to the metadata service using just HTTP instead of HTTPS, and it's still secure. Normally, you would consider HTTP connections to be insecure because they're not encrypted, but because the connection is literally from a machine to itself, there's no way for anyone else to be eavesdropping on that conversation. Now, as a part of setting up this GCE instance on this GCE host, this metadata service will get information from the GCE control plane. In particular, it'll get the startup script and the custom metadata bucket name that we passed along. But when it comes to the scopes and the service account, there's a little bit more that goes on here. In particular, the identity and access management service comes into play, and it combines the scopes and the service account together to create an access token. Now, fundamentally, what this access token allows is for whoever holds it to act as that service account, but scoped down to whatever those scopes would allow. So if the service account allows something, but the scopes do not, then you can't do that with the access token. But the reverse is also true. If the scopes allow something, but the service account doesn't have access to do that thing, then again, the access token won't be enough to be able to do that. Well, we've already seen that the default service account has access to a lot of different things, but you can scope that down on an instance-by-instance basis using the scopes. So for example, by default, you can read from Google Cloud Storage, but you can't write to it. The service account allows you to do both, but the scopes say read-only by default. But imagine if you changed that service account or created a new one, and you didn't give that service account access to any GCS buckets. Well then, no matter what the scope says, that access token will never let you do something that the service account couldn't have done originally. Now, one last thing to call out here about the metadata service is that GCE maintains some project-level SSH keys for us, as we've seen, and those keys will also be passed to the metadata service as a part of configuring this instance. Now at this point, the host machine has everything it needs, and so it lets the GCE control plane know that it's got it, that the instance is running, and then flips the communication around and starts telling the GCE control plane about what's happening with that instance. It'll tell it things like, the instance is still running, or oh, it's shut down now, but it'll also pass along metrics of things that are visible to the hypervisor. Now, the hypervisor is really just the system on the host machine that is running and monitoring all of the instances, all of the virtual machines. And so whatever things are virtualized will be visible to that hypervisor. So for example, when the instance uses a lot of CPU, because that's virtualized, the hypervisor will see all of that processing. And because disk and network access are also virtualized, those things are also visible to the hypervisor. Things that are at the level of the operating system of that GCE instance, those things are not visible to the hypervisor. So for example, the hypervisor doesn't know how much free memory there is in the operating system, because the operating system is just using the memory however it sees fit. Maybe it goes about clearing all of the pages of memory, and so it looks like memory access, even though it's just cleaning things up. Or maybe the operating system hands out a bunch of memory pages to different applications, and so that memory is effectively being used up, even though there isn't any memory access associated with it. Another thing that would not be visible to the hypervisor is things like garbage collection events that happen in the Java virtual machine. Now, I'd like to point out that once things have gotten to this point, the instance is considered to be running. The GCE control plane has handed off the responsibility to the host machine, and at this point, that instance and the host are resilient to a control plane outage. What this means is that because the data has already flowed to it, it has everything it needs to keep running until any issue with the GCE control plane has been resolved. Any metrics or status updates that it would have passed along will just wait on the host machine until the GCE control plane comes back. Now this situation here is exactly why when you see a service outage related to GCE, it'll usually be that you're unable to start or stop or delete instances. Not that those instances stopped running all of a sudden. Sure, here and there an individual host will have trouble and a few instances will get restarted somewhere else, but the system is designed to let all of the instances keep doing whatever they're doing, even if there's a system-level problem with GCE. I think this here is one of the most clear ways to identify the control plane. It's the part of the system that you use to make changes rather than the part of the system that actually does the work. In any case, let's move on and assume that the GCE control plane is humming along just fine. So at this point, the GCE host knows that it needs to start up this instance, and it effectively powers on the virtual machine, which makes the operating system boot and do its thing. Now, as the operating system boots, Debian Linux in this case, it writes its progress to a file called syslog. Now, syslog is a place where lots of different applications will write, and keeping a whole bunch of arrows pointing at syslog will really overcomplicate the diagram, so I'm just going to simplify things and omit those arrows. Now, when the operating system starts up, one of the things that it does is that it starts a program to manage SSH keys. Yes, the actual SSH service will also be started, but what I want to point out here is that this SSH key management system will reach out to the metadata service and grab whatever keys are authorized to connect to this instance. Now, in the case of this brand new project where we didn't set any project level or instance level SSH keys, this is just going to be empty for now. But a core part of why this all works is that this SSH key management system puts a watch on the SSH keys in the metadata service. In particular, the metadata service has a mechanism where you can ask it for any particular value, but tell it if it doesn't have a new one, just wait. Don't answer yet, just answer if it changes. It's actually really easy to ask for this functionality because you just add a query parameter to the metadata URL setting wait for change equal to true. Now, setting this query parameter is triggering something that's called long polling. Now, if you're not already familiar with long polling, that's fine, but it is a really valuable technique to understand. It allows you to basically get an event sent through the normal HTTP system. In particular, because it uses normal HTTP traffic reaching out from the client to a server, it'll be able to use any normal firewall or network configuration to enable web traffic and won't require a lot of complicated management on either the client or the server either. If you imagined this arrow flipped the opposite direction, where the metadata service had to push some information into the GCE instance, that would be a problem because then the instance would have to have some way of accepting and processing that request. You would have to start a server on the instance, and you would have to open up some port so that the connection could come through. But because the instance is reaching out, It just uses the normal system for making web requests and doesn't even require the extra setup overhead that something like WebSockets could have. In any case, moving on, the operating system also wants to run the startup script. The machine image that we're using in GCE comes pre-configured to go and access the metadata service to ask for the startup script. So when it retrieves that, it runs it. Now this startup script starts off by connecting out to the internet to update some things on the local machine, but we're going to ignore the internet connection stuff for now and just talk about how it starts up the Stackdriver agent. Now actually, this doesn't just start the Stackdriver agent either. If you look at the script, it reaches out to the internet, downloads the Stackdriver agent install script, runs that Stackdriver agent install script, which will then reach out to the internet again to get the Stackdriver agent, install it on the machine, and run it as a service. There's a lot of stuff going on, but what matters to the data flow is that it gets installed and starts running. Now this Stackdriver agent will read the data from syslog. In fact, it doesn't just read it, it actually watches that file from this point on, and it's then going to send that data to the Stackdriver logs service. But Stackdriver doesn't accept logs from just anyone. You need valid credentials. So the agent gets the access token from the metadata service, and using that, it's then able to write the logs to Stackdriver. And it continues writing them as new log lines are written. Now I've only pointed out syslog here, but the Stackdriver agent by default will send tons of different logs. It comes pre-configured to send logs for pretty much all of the most popular services. But this agent can do more than just shuttle logs too. It can also write metrics that are only visible from within the VM by asking the operating system what's going on. This can see things like how much free memory there is, something that I pointed out is not visible to the hypervisor. Well, okay, once the Stackdriver agent is off and running, the startup script runs the stress tool. Now this is effectively simulating some work that would need to get done on this GCE instance, so it just processes a bunch of stuff on the CPU. Now, because CPU usage is visible to the hypervisor, that will be sent by the host machine to GCE as hypervisor metrics, and we'll see a spike in the CPU graph for this instance. When stress finishes, the CPU graph will go back to low usage. The next thing that happens is that the startup script reaches out to the metadata service to get the bucket name. It uses that information to create a command for gsutil, telling gsutil to write a particular log file to that bucket we created. But gsutil also needs some credentials, so it too reaches out to the metadata service to get the access token, which then allows it to write the log to the logs bucket. When it's finished running the file, gsutil finishes, and that was the last thing in the script, and then the operating system finishes booting too. Well, there we go. We just got the result that we expected, without having to SSH to the instance or anything. And we haven't used the GCP console for anything since pretty much the very beginning. Now, at any point in time during this process, or after it all finishes, whatever you choose, you can use the GCP console to connect out to these different places to see what's going on. You can check the status of the machine or the metrics that are visible to the hypervisor in the GCE area of the console. You can check whether the file has appeared in the logs bucket in the GCS area. And in Stackdriver, you can watch for the logs to show up, indicating that the startup script was able to install the Stackdriver agent, and the agent was able to use the access token to write the logs. All of this information is visible to you in the GCP console. Well, wow, that took even more animation steps than the Cloud Shell data flow did, but I hope it's been useful to help you validate your understanding of this Challenge Lab data flow and how everything works. Now, if you haven't already had a chance to go and actually do the lab yourself, please do that now before you continue on. And if you have any questions for me, please let me know. And when you're ready, I'll see you in the next lecture. Thank you.